Hi, sixth graders. We are on our last lesson for Unit 10, so you can label your page Unit 10. We're still in our probability unit, and we're talking about theoretical and experimental probability today. So theoretical and experimental probability, what is the difference? Well, theoretical probability is what should happen. So these are two words that you are going to want to write down: theoretical probability and experimental probability. And the shortest definition that I can tell you is theoretically is what should happen. Your experimental probability is what actually happens. So you've probably heard people say, well, theoretically, it should go this way, or theoretically, it's this. So that's the difference, what should and what actually happens. If a coin is flipped 10 times, theoretically, how many times should it land on heads? Well, we know that the probability of flipping a coin once and getting a heads is 1/2, because there's two outcomes, heads or tails. So 1/2. So theoretically, half of the times that I flip it, it should land on heads. So theoretically, I should get 5 times on heads, 5 times on tails. If the coin landed on heads 7 times, what is the experimental probability of the coin? Of the coin landing on heads. So the probability of heads experimentally, so that's, I flipped it 10 times and I got heads 7 times, so the experimental probability then was 7/10. So the theoretical probability, if we write it like this, the probability of getting heads theoretically would be 5/10, because that equals 1/2. So 5 out of the 10 should be heads. But as we know, that never happens, right? This is all just a probability, and it's just kind of what should happen, and then we can see that this is what actually happened. So if you flipped a coin 10 times, you would probably get a different experimental probability than what we got in this example. If a dice is rolled 24 times, what is the theoretical probability of rolling a 5? So we know that if we roll a dice 1 time, the probability of getting a 5 1 time is 1/6. So the theoretical probability of rolling a 5, even if we roll it 24 times, theoretically, I should get it 1/6 of the time. So I should roll a 5 1/6 of the time if I roll a dice 24 times, which again, we know if we roll a dice 24 times, we're not going to get a 5 1/6 of the time. We might not, it's not guaranteed. If I change this to 24ths, so if I go 6 times 4, 1 times 4, I can see that 1/6 is the same as 4 24ths because they're equivalent fractions. So this tells me that theoretically, if I roll the dice 24 times, I should get a 5 4 times. If a 5 is rolled 8 times, what is the experimental probability of rolling a 5? So again, the probability of a 5 in this experiment then would be 8 24ths, which then we can multiply or divide both sides by 8, so then we get 1/3. So that's telling me that I actually got a 5 1/3 of the time. So my experimental probability is greater than my theoretical probability. In the above experiment, what is the experimental probability of not rolling a 5? So if I rolled a 5 8 times and I rolled it a total of 24 times, that means that I do 24 minus 8 and I get 16. So that means 16 times I did not get a 5. So then the probability of not a 5 in this experiment would be 16 24ths. and we can divide both sides, or divide the top and the bottom, numerator and denominator, by 8. So 16 divided by 8 is 2. 24 divided by 8 is 3. So 2/3 of the time I did not get a 5. 1/3 of the time I did get a 5. Notice that if I do 1/3 plus 2/3, then I get 3/3, which is 1. So you either got a 5 or you didn't get a 5. So remember this, not rolling a 5. Remember that's the complementary event of rolling a 5. And then the event and the complementary event together equals 1. If I spun this spunner 40 times, what is the theoretical probability of landing on a 2? So if I look right here, I can see that the probability of landing on a 2, if I just spin it once, is 1/4, because there's 4 equal sections. 2 is one of the sections. So theoretically, if I spin it 40 times, again, the theoretical probability of landing on a 2 is still 1/4. It just means that theoretically, 1/4 of the time, I should land on a 2. So if I change 1/4 to 40ths, so I can see that I can just times it by 10. So theoretically, I should land on a 2 10 times, because that is 1/4 of 40. If I actually landed on a 2 16 times, what is the experimental probability of landing on a 2? So again, probability of landing on a 2, I landed on it 16 times. Again, I rolled it 40, so it's going to be out of 40. So 16/40ths. I can divide 16 and 40 by 8. So 16 divided by 8 is 2. 40 divided by 8 is 5. So 2/5, the probability of landing on a 2, the experimental probability is 2/5. The graph shows the results of an experiment in which a spinner with 3 equal sections is spun 60 times. Oops. So that's an important number. Find the experimental probability of spinning red for this experiment. So let's look here, and we can see that red was spun 24 times. So the probability of red, which this is the experimental probability, is 24/60ths. I can divide both sides, or both the numerator and the denominator, by 6. So 24 divided by 6 is 4. 60 divided by 6 is 10. And then I can look again, and I can see 4 and 10 can both be divided by 2. So I'm going to simplify it again. So 4 divided by 2 is 2. 10 divided by 2 is 5. So the experimental probability of spinning a red is 2/5. The theoretical probability of getting red would be 1/3, because there was 3 equal sections. Red was one of them, so the probability of getting red is 1/3. Compare the experimental probability you found to the theoretical probability. So we have theoretical is 1/3, experimental is 2/5. Well, I know 3 and 5 can both go into 15, so I'm going to change them so they have the same denominator, so then we can compare them a little bit better. So I can do 3 times 5 to get 15, and then times 3 down here to get 15, so this would be 5/15. This would be 6/15. So the probabilities are really, really close. So but I can see that my experimental probability is higher than my theoretical probability. But again, they're really close. And if we, the more that we spin the spinner, like if we were to spin it 1,000 times or 2,000 times, the more that we spin it, the closer and closer that our theoretical and experimental probability are actually going to be. All right, a video streaming analyst examines last year's video selections of customers. Last year's selections are shown in the table. What is the probability that a person streamed a comedy genre? So comedy is right here. So we're going to take probability of comedy, and this again is experimental probability because this is what happened. Like, these are actual results. So 580 is going to be our numerator because there was 580 people that liked comedy. And then I'm going to add up everything else. So 670 plus 580 plus 450 plus 300. And I get 2,000 people. So now I'm going to simplify this down. Actually, I'm going to leave it like this. So the probability is 580 out of 2,000. Suppose the analyst expects 5,000 customers this year. How many drama selections should be expected? So if we're going to make it out of, so 580 out of 2,000, so that also means that out of 2,000 people, 450 people liked drama. So if we change it to 5,000 on the bottom, and I know that if I multiply this times 2.5, I get 5,000. So I'm going to take 450 and I'm going to multiply that times 2.5 also. Because if we do, oops, wrong. Oh my gosh. Sorry, I'm trying to erase this and it's not letting me. Well, I was going to write it, I'm going to write it over here. 450 over 2,000 equals, and now we want to change it to 5,000. So I can see 2,000 times 2.5 equals 5,000. So I'm going to do 450 times 2.5. And I get 1,125. So that's theoretical. So now we went from experimental. This is my experimental probability. Like, this is actually what happened. So theoretically, of course, if we ask 5,000 people, we're going to be a little off of 1,125. But based on this information, then theoretically, 1,125 people out of 5,000 would also like drama. So just to recap, theoretical probability is what should happen. So theoretically, if I flip a coin, I should get heads half the time, tails half the time. Theoretically, if I roll a dice, I should get a 1 1/6 of the time, a 2 1/6 of the time, a 3 1/6 of the time, and so forth. Experimental probability is what actually happens. So I flip a coin 50 times, I get heads 30 times. So then 30/50ths is my experimental probability. And then, like I mentioned before, the higher the number of experiments, the closer that the theoretical and experimental will most likely be. All right, here's your questions for you to solve. So do these at the end of your notes. Remember, if you could please include these in your picture and in your submission. So if there's somehow that you could have your notes and these questions in your submission, that would be great. And then tomorrow, there's going to be the answers posted to these questions. So I want you to check your answers tomorrow so that it's a good self-check-in and good for you to know if you're getting these correct or not correct. And if you don't get them correct, make sure you cross them out and make your corrections so you know, and that you can move forward doing well on your practicing and doing well on your theoretical and experimental probability. All right, and then just a reminder, don't forget to upload your notes. The submission is right underneath the video link that you found for this video. Have a great day. Talk to you guys soon.